Okay, now for the transformation here. In our equation, the transformations are going to show up as numbers multiplied in front of our function, added or subtracted to our function, or added, subtracted, multiplied, or divided by our input, our angle. So just to kind of generalize all of them, we can write our function this way, both sine and cosine. And from this form of the equation, this is kind of just like a template. Whatever that A is, the absolute value of it is called the amplitude. And I'll put the definition of amplitude up here. But the amplitude is half of the distance between the maximum and the minimum. So kind of how high does it go or how low does it go? Okay. The B in this equation tells us the period. So if we do like a horizontal stretch or compress, that's going to change the period of our graph. So the period can always be calculated as 2 pi over b. Those numbers inside of the parentheses also will kind of shift our graph left or right. So if there is a phase shift, which is just a horizontal shift, it would be given by c divided by b. And that number on the outside would give us a vertical shift. So that d is a vertical shift. Okay, so let's see if we could graph a function that has a transformation. So in comparing this to our original sine function, the only thing different that we have going on here is that 2 in the front. So what will that 2 change about our graph? So the 2 is multiplied in front of our sine. That is going to change the amplitude. So this is A. So it's going to change how high and how low. We're changing the range of my function. The amplitude is the absolute value of A, and here A is 2. This is A. So absolute value of 2 is just 2. That's the amplitude of this function. Now I want to graph one full period. Let me double check and make sure that the period hasn't changed. Period is 2 pi over b. Here I don't have anything. B would be multiplied by that x. And there's nothing there, so it's just a 1. So 2 pi over 1 is still 2 pi. So period has not changed. So when I'm graphing this, I'm still going to graph a period from 0 to 2 pi. And I'm going to have all of the same x values because I haven't changed the period. But my y values are going to change because they're all multiplied by 2. So that's going to change my high point and my low point. I made a table. Let's see, pi over 2, pi, 3 pi over 2, 2 pi. You can plug these if you're not sure. So there's a pattern here, and you can use the pattern. But if there's ever any doubt, you plug these x values into the function, you evaluate that sign, and then you multiply it by 2. So like plugging this x into the equation to get y. It should always satisfy the equation. So sine of 0 is 0, and 0 times 2 is still 0. Sine of pi over 2 is 1. Let me write this in. So 2 times sine of pi over 2. I would evaluate the trig function first. So sine of pi over 2 is 1. So I end up with 2 times 1, and that is still 2. So I do that same thing to get the negative 2 there. And I'm going to plot these points to draw the So I'm using the same x values because nothing happened with the period. But I am changing my amplitude, so my graph should go up to 2 and down to negative 2. All right, so plotting those points, 0, 0, pi over 2, 2, pi 0, 3 pi over 2, negative 2, and 2 pi 0. There is one period of the sine graph. I'm going to put the arrows on both sides to show that it continues. And there we go. Now, let's do another, and let's say this time we've got our 2 inside with the x like this. A little note here that this means exactly the same thing as 1/2 x. Let me see that. If I were to multiply 1/2 times x over 1, then x will go on top. If I want to say the same, I get x over 2. So just a different way to write the same thing. But when I separate the fraction, it makes it a little bit more obvious that the 1/2 is b. Hopefully. So here we've got b being 1/2. B is just going to change our period. So I have nothing multiplied in front of my sign. So there's just a 1 in there. So amplitude is 1. So amplitude is 1. The period is going to change here because b is not 1. So the period is always 2 pi over b. And here our b is 1/2. So 2 pi over 1/2 is the period. All right, so that means we need to flip the 1/2 and multiply. You need to make that 2 steps to 2 pi divided by 1/2, and then flip the second fraction and multiply. You get 2 pi times 2 over 1, which is 4 pi. So now our period is 4 pi. So to graph one period of this function, we're graphing from 0 to 4 pi. Now, to figure out what goes on our chart, we need to know how are we dividing up this x-axis? Where are our key points going to fall? And you can always figure that out if you divide your x-axis into 4 equal pieces. So however far you're going on the x-axis, in this case 4 pi, I want to divide that into 4 equal pieces. The measure of each piece is going to be pi. So I'm going to go from 1 pi, 2 pi, 3 pi, count pi. All right, so those are our key points, and those are going to be the points where we get our middle value, our high value, our low point, same as before. All right, so what I'm putting out here for my x's is 1 pi, 2 pi, 3 pi, 4 pi. Starting at 0 still. 0, 1 pi, 2 pi, 3 pi, 4 pi. And nothing has changed about the amplitude, so I should still be getting, this is a sine, it's going to start at 0. So I should get 0, 1, 0, -1, 0. I'm not sure. I'm going to plug these numbers into my function. So look what happens when you plug these x's into the function. They're all getting divided by 2, and then you're taking the sign. So let's say you have, you want to plug 2 pi in there. You're going to find sine of 2 pi over 2, which is sine of pi, which is why you still get 0. Right, so on those points, only from amplitude on my graph. And then I'm just going to plot those key points. All right, so what changed in this graph is that the period changed. So it's kind of like a stretched out version of our original sine. It's stretched horizontally, and so that changed out all of our key points.